हेलो एवरीवन, आज हम करने वाले हैं केमिस्ट्री का चैप्टर 1 सम बेसिक कंसेप्ट्स ऑफ केमिस्ट्री। ये नोट्स मैंने बनाए हैं और मैं नोट्स को अभी पढ़ूंगी। अगर मुझे कहीं लगेगा कि मुझे एक्सप्लेन करना चाहिए तो मैं वो भी एक्सप्लेन भी करूंगी। ये मैंने इसलिए बनाया ताकि आपको इस चैप्टर का बेसिक मिल सके। फर्स्ट, chemistry. It is defined as that branch of science which deals with the study of composition, structure, and properties of matter and the changes which the matter undergoes under different conditions and the laws which govern these changes. Basic constituents of matter are atoms and molecules. Now, importance of chemistry. First, supply of food. Second, contribution to better health and sanitation. Third, transport and communication. Fourth, nuclear or atomic energy. Fifth, saving environment. Next is matter. Anything which occupies space and have mass is known as matter. So, as we know, there are three physical properties of matter. First is solid, second is liquid, and third is gases. Solid. Particles are held very close to each other. Second, have definite shape and volume. We know that like a rigid body you can take, like pen you can take. Pen particles are very tightly packed. So it have very definite shape and volume. And the particles are close to each other, very close to each other, like they are packed. Second is liquid. Particles are close to each other but they can move, like water. Have definite volume but no definite shape. Like water, if you put in a glass, it will take the shape of a glass. If we put in a jug, it will take the shape of a jug. Next is gas. Particles are far apart as compared to solids and liquids. Do not have definite shape and volume. See, we can't measure gas weight, and it do not have any volume also. It do not have any shape also. And particles are very loosely packed. It will fill up all the space which will be given to it. Next is chemical classification of matters. First is mixtures. A material containing two or more substances in any proportion. These are of two types. Homogeneous mixture. Its composition is uniform throughout. And second is heterogeneous mixture. Its composition is not uniform throughout. See, mixtures and pure substances. We can classify matters chemically into two ways. First is mixtures and second is pure substance. Mixtures, there are two types of mixtures, homogeneous and heterogeneous mixtures. Now let us come to pure substance. A material containing substances in fixed proportion. These are of two types. See, like in the upside one also there were of two types, so pure substance are also of two types. First is elements and second is compounds. Elements, a pure substance that contains only one kind of particles. These may be atoms or molecules. Second, now let us discuss about compounds. A pure substance that contains more than one kind of elements or atoms is known as compound. Now let us discuss about atom. It is the smallest particle of an element which may or may not be capable of independent existence. First we know that one of our scientists said that atom is the smallest thing, but now there are many like electrons, protons, and neutrons. Properties of matter. There are two types of properties of matter, like physical and chemical. We know physical we have discussed, and chemical also we have discussed above. So now let us know more about them. Physical substance identity remains same. Chemical substance identity do not remain same. Understood this? Physical quantities. All such quantities which we come across during our scientific studies are known as physical quantities. Next is unit, the standard of reference chosen to measure any physical quantity is known as unit. SI unit, we know this thing. SI unit like acceleration we are discussed in class 9th and 10th, speed, these all have SI units like meter per second, meter cube, volume have meter cube. So what is SI unit? SI unit is International System of Units. There are 7 basic units. Length, which is denoted as m, mass into kg, time, seconds, electric current, ampere, thermodynamic temperature, Kelvin, amount of substance, mole, luminous intensity, CD. This we have discussed. These are 7 basic units by which all other units are formed. Now let us discuss more in detail. Physical quantities, symbol, SI unit, and they are also symbols. Length. Length symbol is L and its SI unit is meter, and the symbol of its SI unit is M. Mass M, kilogram, kg. Time T, seconds, S. Electric current I, ampere A. Thermodynamic temperature T, Kelvin K. Amount of substance N, mole. Mole same is there, just E is removed in its symbol. Luminous intensity IV, candela, CD. Next is mass. The amount of matter present in a substance is known as mass. Mass is always constant. Anywhere we go, like on moon, earth, the mass of a person will be constant, whether the weight may or may not vary. Now weight, the force exerted by gravity on object. Weight vary from one place to another, like on earth gravity is there, on moon gravity is not there. So this we have studied in class 9th, that 1/6 of earth weight is on moon. Yes, now we have studied in class 9th and we have derived its formula also. So weight may vary, like on earth of a person weight will be something else and on moon something. Volume, amount of space occupied by a substance. Volume is measured in cube power m raised to power cube. Next is density. Density of a substance is its amount of mass per unit volume. Next is temperature. There are 3 common scales to measure temperature. First is degree Celsius, second is degree Fahrenheit, and third is Kelvin. And now this is the main thing, relationship. We will discuss this in thermodynamics chapter of this chemistry only. So it is very important. Manywhere we will use this formula to calculate. Degree Fahrenheit is equal to 9/5 degrees Celsius plus 32. And Kelvin is equal to degree Celsius plus 273.15 Kelvin. It will be Kelvin. When we will add degree Celsius to 273.15, then the Kelvin will come out. Degree Kelvin. Okay. Next is precise. If the values of different measurements is close to each other and hence close to their average value, the measurement is said to be precise. The average value of different measurement may not be close to the correct value. This we will discuss further, like precise and accurate. There are 2 types of measurement, precise and accurate. It will be in points, like 2 pointers, like an accurate is, we have got a value 2.5. So precise will be 2.05, 2.02, means they will be near to each other, they will be close to each other, but they will not be close to the accurate value. Now let us come to next topic. Next is accurate. If the average value of different measurements is close to the correct value, as I told in the above, we have given an example. Yes, no? The measurement is said to be accurate. The individual measurements may not be close to each other. Means they cannot be close to each other. Like I have given an example like 2.05, 2.02. These are precise. And like 2.1, 2.3, 2. Like they will be far apart, but they will close to the correct value in accurate. This thing is there one thing that a value can be both precise and accurate. Next is significant figures. The total number of digits in a number including the last digit whose value is uncertain. There are different rules of significant figures. These significant figures we will learn very nicely in other chapters. In this basic will be given. Rules of significant figures. First, the result of an addition or subtraction should be reported to the same number of decimal places as that of term with the least number decimal place. Second is the result of a multiplication or division should be reported to the same number of significant figures as is possessed by the least precise term used in the calculation other than exact numbers. Now rules for determining number of significant figures. All non-zero digits as well as the zeros between non-zero digits are significant. Like we can take 2 and many other things. Let us take a number. See, 285. Let us take this. So in this, how many significant figures you can see? 2, 8 and 5. These all three are significant figures. Like see, this is there a number 205 we are taking. Then in this 2, 0 and 5. These three are also significant figures. As this 0 come between these 2 and 5 which are non-zero digits. So now let us discuss second point. Zeros to the left of the first non-zero digit in a number are not significant. Like let us take now this example 0.08. So in this these two zeros are coming before 8. So these are not significant. Only this 8 is significant. So here is only one significant figure. Now let us come to next point. If a number ends in zeros, but these zeros are to the right of the decimal point, then these zeros are significant. Like now let us take for this third another example. 0.0205. See, as we know, in the second point we came to know that these two are not significant figures. Now here there is a point. So this 0 and this 0, they are significant figures. This third law, this third rule tells us this thing only, that the 0 which is right to the decimal point. See here, this is decimal point and here these are right to the decimal point. So these are significant figures. Understood? Now let us discuss next point. If a number ends in zeros, but these are not to the right of a decimal point, these zeros may or may not be significant. Now let us take an example to clear all our doubts. See, in this it is given very clearly, which I explained in the above rules. These are not significant. These are significant. This also significant. Means these zeros are significant, but these are not significant, as the rule states us very clearly. In this, these are not significant because there is no decimal. They are not right to the decimal. So these are not significant figures, these zeros. But this zero is significant because it is between non-zero numbers. Okay? Now scientific notation. Now let us discuss this scientific notation. See, first it was difficult to write many long digits like 0.0000 and so on, this much big digit. We can't write this much big and our solution will come this much big. So how we will do? So our scientists thought a short form to write this, which is scientific notation. N into 10 raised to power n. So this scientific notation, this our scientists thought that it will make this writing easier. So now let us take an example to show this very easily. It is given a number 0.0001 and 6. So how to write this number in scientific notation? Easy. 1.6 into 10 raised to power minus 4. This is known as scientific notation. This is a simple number and it will be scientifically noted in this form. Understood? And this side, this is an coefficient, this 1.6. This number, the scientists decided that it will not be greater than 9. Means it will be a single number. Here after 1, there can be how many numbers, but here only one digit will be there. This 1. Here 8 can be there, 6 can be there, 3 can be there. Till 9 it can be there, but more than 9, 10 it can't be. 2-digit number can't be before point. Okay. Now laws of chemical combination. There are 6 laws of chemical combination. First law, law of conservation of mass. As we all knows this law, this is very common law. According to this law, matter can neither be created nor be destroyed. It is known as law of indestructibility of matter. Next is second law is law of definite proportion. According to this law, a given compound always contains same elements combined together in same proportion by mass. It is known as law of constant composition. So now let us discuss about its limitations. The law is not applicable if an element exists in different isotopes which may be involved in the formation of compound. Second is the elements may combine in the same ratio but the compounds formed may be different. Now let us discuss third law, law of multiple proportion. According to this law, when two elements combine to form two or more compounds, then the masses of one of the element which combined with the fixed mass of the other bears a simple ratio to one another. Let us discuss this law very briefly. Like example, we can take for example hydrogen combines with oxygen to form two compounds, namely water and hydrogen peroxide. See, now let me show you. H2 plus O2 to water. H2O. Balancing we will not do. Let me tell you just we are giving a brief example. In this S2 is taken 2 gram. Here this O2 is taken 16 gram and water is 18 gram. This over our one example. Now next is H2 plus O2 to H2O2. In this hydrogen is 2 gram and oxygen is 32 gram. And this hydrogen peroxide is 34 gram. See, I told an example now only that hydrogen combines with oxygen to form two compounds. In the first, water is formed. In second, hydrogen peroxide is formed. Now this 18 gram and 34 gram. These are its gram like of water and hydrogen peroxide. Now if we will take this oxygen 16 gram and this oxygen 32 gram. Here this way 16 upon 32. If we will divide, then 1 jar and 2 jar. So the result is 1 by 2. It is in small ratio, whole ratio now. So this rule states that. Now understood? Now there are some limitations of this rule law also. Now let us discuss its limitations. A. The law fails when applied to some organic compounds of carbon. Second means B. Known stoichiometric compounds do not follow the law of multiple proportion. Now let us discuss fourth law of reciprocal proportion. This law of reciprocal proportion is not in our syllabus, means related to this there is no very nice explanation in the NCERT book, but still I will explain you this reciprocal law. According to this law, the ratio of the masses of two elements A and B, which combines separately with the fixed mass of the third element C, is either same or some simple multiple of the ratio of the masses in which A and B combine directly with each other. So means I know this law is now clear to you. Now let us come to fifth. Gay-Lussac's law of gaseous volume. According to this law, when gases react, they do so in volume which bears a small whole number ratio to one another and to the value of products formed if gases are at the same temperature and under the same pressure. So now let us take an example. 100 ml of hydrogen combines with 50 ml of oxygen to give 100 ml of water vapor. In this, the volumes of hydrogen and oxygen which combine bears a small ratio, simple ratio of 2:1. Like we will take, there was 100 liter of hydrogen, 100 upon 50. 50 was oxygen. So here 0 से 0 cut. 1 jar 2 jar is equal to 2:1. Came our example solved. So this Gay-Lussac's law of gaseous volume states. Now sixth one, Avogadro's law. According to this law, equal volumes of all gases under similar conditions of temperature and pressure contain equal number of molecules. Now let us discuss its applications. First, calculation of atomicity of elementary gases. Second, finding relationship between molecular mass and vapor density of a gas. Third, finding relationship between mass and volume of a gas. So these are its application. Means Avogadro's law is used in these three for calculating the atomicity of an elementary gases, and second means to show the relationship between molecular mass and vapor density of a gas. Third, the relationship it is finding between the mass and volume of a gas. Now let us discuss about Dalton's atomic theory. First, matter consists of indivisible atoms. Means this Dalton states this thing that the smallest unit is atom, which is indivisible. It cannot be divided. But now our scientists have discovered electrons, protons, neutrons, alpha, beta, many some subatomic particles. So this law was due to, according to modern atomic theory, it is being detached, eliminated. Now let us come to second. Atoms of same element are identical in size, shape and mass. Atoms of different elements are not identical. When atoms combine with one another to form compound atoms, they do so in simple whole number ratio. An atom can neither be created nor be destroyed. So this was still here according to Dalton's atomic theory. Now according to modern atomic theory it is very different. Now let us discuss about according to modern atomic theory. According to modern atomic theory, first, atom is no longer considered to be individual. As I told that there are many subatomic particles which are discovered like electrons, protons, alpha, beta and many more. Second, atoms of same element may have different atomic masses. Third, atoms of different element may have same atomic masses. Means same elements may have different atomic masses. Their masses can be same of the same elements, and they can be different also of the same elements. And of the different elements, the masses, atomic masses can be same also and different also. So now according, it eliminates the rules, or we can say theory, which is given by Dalton. Now fourth is the ratio in which different atoms combine with one another may be fixed and integrally, but may not always be simple. As we have discussed above, that Dalton mentioned that they will be in simple whole ratio, but the modern atomic theory eliminates this theory. Atom is no longer destructible. Now let us discuss atomic mass. Atomic mass of an element is the number of times an atom of that element is heavier than an atom of carbon taken as 12. One atomic mass unit mu is equal to 1/12 of mass of an atom of C12 isotope. Fractional abundance of an isotope is the fraction of total number of atoms that is comprised of that particular isotope. Now average atomic mass. Sum of masses of its isotopes each multiplied by its fractional abundance. Now molecular mass. Sum of atomic masses of an element present in a molecule is known as molecular mass. Now let us discuss next topic, which is mole. See guys, this mole concept is very important in chemistry, and most of the students do not understand this mole concept. A mole is defined as that amount of substance which has mass equal to gram atomic mass if the substance is atomic or gram molecular mass. 1 mole is equal to gram atomic mass if substance is element is equal to gram molecular mass if substance in molecular. Understood? Now next is Avogadro's number. Na, which is denoted as Na, is equal to 6.022 into 1023. Means this is a constant. It is also known as Avogadro's constant. Next is molecular mass. The mass of 1 mole of a substance in grams is known as molar mass. Next is percentage composition. Percentage of an element or constituent is equal to number of part by mass of element upon molar mass of compound multiplied by 100. As we all know, percentage we are coming out by multiplying by 100. Next is empirical formula. The chemical formula which expresses the simplest whole number ratio of atoms of various elements present in one molecule of compound. Next is molecular formula. The chemical formula which represents true formula of its molecule. It expresses actual number of atoms of various elements present in one molecule of compound. Molecular formula is equal to N into empirical formula. Now next is balancing chemical equation. This we have done very nicely in our previous classes. There are two methods to balance an equation. First is heat and trial method and second is partial equation method. Now limiting reactant. Reactant which react completely in the reaction are known as limiting reactants, and the reactants which do not react completely, or we can say reactant which is not consumed completely in the reaction, is known as excess reactant. Next is mass percentage. The mass percentage of a solute in a solution is the mass of solute in gram present in 100 gram of solution. Mass percentage is equal to mass of solute upon mass of solution into 100. Next is mole fraction. The mole fraction of any component in solution is equal to number of moles of that component divided by total number of moles of all components. Mole fraction of A is equal to number of moles of A upon number of moles in solution, or we can say number of moles of solution. Next is molality. See guys, these two terms molarity and molality, these are very similar, means we mostly confuse in these two terms, that how to define them. See, very clearly I will explain this. Molality. The molality of a solution is defined as the number of moles of solute present per liter or dm cube of solution. Molality formula is number of moles of solute upon volume of solution in liters. See guys, this in liters you remember it very clearly. Molality. The molality of a solution is defined as the number of moles of the solute dissolved in 1 kg, means 1000 gram of solute. Molality is calculated as number of moles of solute upon volume of solution in kg. See, in upside molarity in liter it was, and in molality in kg it is. Means the formula is same, but the volume of solution is taken in different units. Understood? I know now you understood this very clearly. These two formulas. Here it is in liters and here it is in kg. That's all guys. This much only we have to discuss in this chapter. Means this was only the basic of this full chapter. I hope you have understood it very well. And if you have any confusion, then tell me in comment. Thank you, love you. Have a great day. Best of luck.